This is reading week 7 for Physics 2212. This week we learned more about electric potential. Specifically, we watched videos on the path independence of electric potential. And I already knew about this concept of path independence from my chemistry courses when we learned about state and path functions, but I had yet to apply this concept to my physics courses. And although we find the change in electric potential by taking the scalar product of the electric field vector at small displacements along the path and then summing them up, the actual path taken does not matter. Rather, the only initial and final positions affect the change in electric potential. I was interested in why the change in electric potential is path independent and thought that it might be because the equation seems to model that of a point charge. When I tried to look up other resources on this, I couldn't find much, but I ended up coming across something else that I thought was pretty interesting. Electric field is actually a gradient of potential, and here gradient is the equivalent of a derivative in higher dimensions. And the relationship between electric fields and electric potential can be modeled for non-symmetrical and symmetrical cases. In the equations, the del operator is used for Cartesian coordinates and represents the sum of partial derivatives in the 3 unit vector directions. We also looked at an example where the starting point also serves as the ending point, or a round trip example. Once again, this is path independent, so there was no change in electric potential, and this is because energy is conserved. It's not created or destroyed. One of the examples that I found to be quite confusing and really tricky was the charged plate and charged shell example from the second video. However, once they applied the principle of superposition, things began to make a little more sense. To get the total change in electric potential, you have to break up the system by summing the change in electric potential from the plate with the change in electric potential from the shell. As an environmental engineering major, I am studying how different human actions and lifestyles can negatively affect the environment and the planet in general. And obviously, our continued use of electricity and devices that have electric potential energy greatly impact our planet in a negative way. And some of these objects that have electric potential energy when they're turned off include things that we use every day, like light bulbs, TVs, cell phones, and even your car headlights when they're turned off.